Right. I'm quickly going to go through a really simple demo of how to build in a panic button or a garage door opener, anything. Could be anything. But this is basically going to work on 315 megahertz technology. And in essence, it's a really simple circuit diagram. We are just going to have our Raspberry Pi, which is connected via wireless to a home network, and the GPIO board of the Raspberry Pi is going to be connected to a breadboard, and the breadboard really has very simple circuit, which I'll show you in real life. We're going to have 315 megahertz receiver over here. It's going to be our board, which is coming from Adafruit. Has a couple of pins. It works on 5 volts, ground, and a signal pin. There are others which we won't be using. And you will see a really long antenna. It's very important to have that long antenna because it increases the range. The second pin is ground, which I won't bother marking, and the other pin is the signal pin. Basically, we are going to have a key fob, which is going to act as our panic button, which when you press the button sends this radio signal picked up by the receiver, which outputs a high on the pin. I wanted to then sense that signal on the GPIO of the Raspberry Pi, which and then is picked up by my laptop, which is also on the wireless network. All that's needed, this works on 5 volts, so we needed a simple voltage divider. If you're interested, the values are basically 10 kilo ohms and 4.7 or 4.1 kilo ohms. You can do a simple voltage divider equation to find the right one. The important thing is that when activated, the voltage over here should be 3.3 volts or something very close to it. This was then connected to GPIO's number 17 on the Raspberry Pi, and I had a very simple Python script listening on the Raspberry Pi for edge rising or edge falling and sending a signal to the laptop. Okay, let's see it in practice. There's a bit of tangle of wires over here, but that's from previous projects. But here you can clearly see the really long antenna, which I uncoiled. It gave me much better range. Here, very faintly, you can see the voltage divider. Those are the two resistors making up the voltage divider. And over here, going from the junction of the voltage divider, you can see the connection to the Raspberry Pi. Obviously, that is our wireless adapter. Right around over here, there's PC on wireless, which is already listening to the Raspberry Pi. Let's stop that and start it again, shall we? Okay, so there's the Python script, and we'll just leave that listening over there. Back down here, you can see the key fob. This is also from Adafruit, and it's a single button. Took a bit of playing around, but figured out that back on the receiver, you can see there are quite a large number of pins, but this particular key fob activates D2. So hopefully, back down over here, if I now press the button, yep, we get it. So let's do it again. This could obviously trigger anything really. I can keep going. It has quite a good range, about 20 meters, and it works through walls, very thick walls. So it seems like it's a good solution. Taking it further, we could also use a relay board. This is from SainSmart, and this relay board can basically run normal mains appliances. You can just about see that it's rated for 250 volts AC. So we would be able to connect something like a speaker or even a siren, which when we press the button, the panic button, the GPIOs on the Raspberry Pi would immediately trigger the relay board, and I'll show you this really quickly. We just need to connect this. Here all I've done is I've connected the VCC, the supply, to the Raspberry Pi 5 volts, and the ground over here to ground. Then I have a floating wire, which is this blue one over here, which is also connected to ground, because maybe a bit counterintuitively, the relay board is triggered when the signal input, which are these pins over here, these pins in the middle, when they go too low. We can use any one of these, so every signal pin is bound to a different relay. Those are the indicator lights that a relay has been tripped. So if I grab this wire and stick it, for example, to, I don't know, IN4, maybe, it should trigger. There you go. So that's one. You could actually hear it. You could hear the relay click. Let's go to another one. There we go. So the idea is you press the panic button, that gets triggered, and you also get some